On mute. Change over. Transition. Hello. Okay. So we're looking at variable speed DC drives. And the first thing we looked at we've seen the rectifier type. And which we saw the single phase dual converter, single phase semi controlled, fully controlled, and we saw the three phase control one too. So now I come to look at the chopper type. The rectifier type is used if the supply is AC, right? AC supply. You know, the rectifier does what? Rectifier takes AC, gives us DC. And once I can vary the firing angle, I can vary the output voltage and control the speed. The chopper is usually the supply is DC. If you have a DC supply, then we use the chopper circuits. Let's see how the variable DC chopper works. Okay, let's see how it works. This is how it works. I have a switch. I have a diode connected like this. I have the armature here. So I have the supply voltage Vs here. This Vs gives certain V naught to the motor, certain voltage to the motor. This is a switch. The motor draws certain current IA. This is the source current IS. Right. Now I can control the frequency of the switching by pulse. So I have on state, off state, on state, off state, on state. This is the on, this is the off. So we know that duty cycle is the period for which the signal is on over the total period. So this period here is dt, d of t, right? T on dt. Then the total period here is my t. So that's what you must know. So when I close this, when it's in the on state, what happens? When it's in the on state, let me draw how the output voltage looks like. When it is in the on state, what happens? Alright, I record a voltage at the output V. Right? V here. Like this here. So this is when it is in the on state. When it's in the on state, I have my V here. Now the magnitude of this V is equal to what? Vs. Right? The height is Vs. You know that is dt. Let me find the average value of this voltage here. That average value of a signal is equal to what? Area over the total period. Area over period. The area of this signal here is area of a rectangle. That's what length times breadth. So Vs times dt over the total period. That give me the average. Let me call it V naught. Average output voltage V naught. So this means that the V naught is equal to what? Vs times D, delta Vs. This is the first formula to know. The average output or the DC voltage that comes out of the rectifier and connects to the armature of the motor is given by the duty cycle times the source voltage. So once I'm able to vary the duty cycle here, I'll be able to vary the output voltage V naught. That's basically what I'm doing. I vary the duty cycle, I vary the V naught, hence I can vary the speed. The next formula worth noting, this is formula 1. So we say that duty cycle is T on, period for which the signal is on over the total period. This is another formula to know. The next thing, if this is a lossless system, it means that what? Pi is equal to what? P out. Pi is what? Pi is Vs Is, right? P naught is what? P naught is V naught Ia. Are you following? But I know that V naught is what? V naught is delta Vs. So I can write this as delta Vs Ia. Vs for Vs. It means Is is equal to what? Delta Ia. So note the difference here. The output voltage is delta times the input source, but here the input current is delta times the output current. That's the second formula worth noting. This formula here. So we know this V naught is delta Vs. We know I is delta Ia. Now let's find the equivalent resistance seen by the source. The equivalent resistance seen by the source is Vs over Is. I know my Vs is what? Vs is Vs, is what? Delta is, delta IA. So it can be in this form, it can be in this form, it can also be in the form V naught over delta, that's Vs, over Is. Once I know these three relations here, I can make any of them the subject and find what I want to find. I can make any of them the subject and find what I want to find. So that's this part. So let's read this part, but the main thing is this formula here. I spoke about this formula too here. This is a drawing which I drew. We know P naught, we know Pi. Okay. Yes. I also know the equivalent. So that's it here. So let's delve into this question. A DC separately excited motor is powered by a DC source. I have a separately excited motor, right? This is my amateur here. It's powered by a chopper. Let me represent the chopper with a box. This is a chopper. It takes in some input Vs, gives me some output V naught. That drives the motor. Okay. The question, the Vs was given as 600 volts. They also gave me what? They also gave me the RA 0.05. RA. RA here is 0.05. IA. Amateur current is what? It was given as 250. Then they gave me the field current as 2.5 amps. It's all in the question. So the first thing is for us to find what? Find. They give us duty cycle to be 0.6. Duty cycle D 0.6. This is that find what? Find the input power from the source. Input power from the source PI. That's VSIS. We know VS to be 600. We know IS. We don't know IS, but we know IS is called what? IS is delta IA. This is VS delta IA. VS is 600. Delta is 0.6. IA is 250. So this will give me 90 kilowatts. That's the A. The B says that was find the equivalent impedance input resistance of the chopper. So the R equivalent is what? Is Vs over Is. That's Vs over Is is delta Ia. So delta Ia 0.6 times Ia 250. That was 600 over 0.6 times 250. That's 4 ohm. This part is more about formula. So you see, if you take the rectifier part and the second part, this part is formula work. First, know the formula, understand where it's coming from, how it applies to the speed control. Then you can work around it. That's it. Then the C says that find the motor speed and the torque. Let's find the torque first. This what torque is K phi IA. But we weren't giving K phi, but I've said K phi is equal to KVIF. So torque is KVIF IA. That's all. I know I have all of them. I have my KV here, KV here, I have my IF here, I have my IA here. I multiply them to get my torque. Now I have my torque. I can find my speed as speed is equal to what? VA over KVIF minus RATE rate over KVIF squared. I have my VA. I can find my VA. That's it. The VA, which is the voltage of the motor, is the same as the output or the this is V naught here because this V naught that goes to the VA. I can find V naught. So V naught is what? Delta VS. So I find my V naught delta VS. I put it. I know delta. I know V. I put it here. I know KVIF. I know RA. I found the torque. So I have everything to find my speed. So that's it. So that's how you deal with this question. That's how you deal with this question. So you find everything you need. Yeah. Resistance. Everything we need. The torque is given by here. So that's it. That's it for that question. Mm. Example 13. A trolley bus is driven by a 150 horsepower 1500 rev per minute 600 volt DC series motor. The rated current is 200 amps and the total resistance of the armature and the field is 0.1 ohm. The bus is fed from a 700 volt DC line. A chopper controls the torque and speed. The chopper frequency varies from 50 Hz to 1600 Hz, but the on time T on, which is equal to delta T, is equal to 600 microseconds. It says that find the chopper frequency and the current drawn from the line when the motor is at standstill and drawing a current of 240 amps. So let's see what we can do with the fellas we have. So it's a chopper. We have a chopper here, right? It's drawing what? It's drawing 700 volts. It's going to the motor. The motor is going to, that motor has a what? It's rated this. So the motor is rated. Rated voltage is 600. Rated current is 200 amps. So the motor is drawing 200 amps, 600 volts, right? Now, it says that what? We've been given the D on delta T is equal to 600 microseconds. So duty cycle of the period is equal to what? 600 microseconds. I must find the frequency, right? And that was okay. So let's see. So it is that find the chopper frequency. Find the chopper frequency. That's A. And the DC current drawn when from the line when the motor is at standstill. So when the motor is at standstill, let's see. You know that omega is what? It means omega is equal to 0, right? Okay, so for each of them, you have to find the frequency and the power, right? Sure. Let's see. I find my, because it's at standstill, it means my E is 0, right? E is 0. So let me find my output voltage, 24 volts. Right, let me. E is what? E is K5 omega. Omega 0 means E is 0. It means my V naught is equal to IA RA prime, total resistance, right? So I'll find my total resistance here. Once I have my V naught, I can put in my V naught into this formula here to find my delta. So I have my delta here. And once I have my delta, I know that what? I know that delta T is equal to 600. So I can find my period at 600 microseconds over the delta. Once I have my period, I can find frequency as 1 over period. So that's how the question was solved. Frequency is 1 over the period. So that's it here. That's it here. And the question is that also find the power. And find the current drawn from the supply. That's the next question, right? Find the current drawn from the supply. So we know that P is equal to IV, right? So P is equal to IV. So PA output power is equal to us IA V naught. So IA is equal to what? P over V naught. P over V naught. So that's what you apply here. That's what you apply here. Yeah. Hold on, I'm coming. Okay. Hold on a bit, I'm coming, okay. Okay, so here you find the period, can find the frequency as this, right? Find the current, okay, the current drawn from the supply. Find the current drawn from the supply here. Okay, the current IS, for sure. So, I'm gonna find the current drawn from the supply here. When the IS is what? IS is delta IA, so that's it. Delta IA. Hold on a bit, I'm coming. This part, I'm coming in. This part is this one. Over the supply, let me see, or average source current is what? Is IA, right? So the IA is what? IA is 240. IA is 240, right? Times delta, so that's it. So let's use this method here. This one is simpler. Let's use this method here. So that's it. Then now the B says that, what the B says that find the chopper frequency when it delivers its rated output. When it delivers its rated output. So the rated output means that what? It means that the V naught is supplying at 600. So V naught is 600. We are working with this condition here. So V naught is 600. V naught is delta Vs. So let's find a new delta. We need a new delta to find a new frequency. So 600 over 700. So delta is 6 over 7. That delta here, find a new time and find a new frequency. Then you also find the current the same way. So that's it. So that's how you go about the question. That's how you go about the question. So can you hold on? I'm coming. That's it. So now that's the one quadrant chopper drive. That's the type. So that right, we have the one quadrant chopper drive, chopper type. Let's look at the two quadrant chopper drive type. Two quadrant chopper drive type. So if the speed does not have to reverse but braking is needed, then the two quadrant converter shown below can be used. So this is here, right? This is here. Okay. Over here too. So when it's running in quadrant one, it follows the same characteristics as what we've learned already. Right. So now let's learn how it behaves in quadrant two. Quadrant two, you want to reverse the current. In quadrant two, you want to reverse the current. Quadrant two, you want to reverse the current. Right. This is how the circuit looks like. They're using this part here. Current is going through like this. Flowing. So the first thing you must notice that here the V naught here is equal to 1 minus delta of Vs. That's the first formula here. So here's not delta, but it's 1 minus delta. 1 V naught is 1 minus delta Vs. Okay, that's the first thing. So that's the V naught or the VCH, the chopper voltage, the same thing here. VCH or V naught. That's we can see from here. Okay. So that's it here. Then I know that the power generated, right? The power generated from now is not from the source because you are breaking. So the regenerated power is VA times the chopper voltage, which is now we know that is VS 1 minus delta here. So look here. We are looking at the power generated from here, right? So P is what? The current drawn from here times the voltage, and the voltage here is the chopper voltage. Okay, I hope that makes sense. Okay. Now, another thing also right is that we can write an equation for the back EMF here. The back EMF of the motor, which is now generating, is equal to what? Is equal to this VCH here plus IARA. There's some IARA going through here. Okay. So that becomes this E here. So you also know this formula here. When we know VCH, which is the chopper, which is V naught of VCH, is equal to 1 minus delta of VS IARA. So now the equivalent resistance seen by the generator, which is now the motor, because it's regenerating. The motor is now the one supplying the power. So the equivalent resistance seen is equal to what? E over IA. Let me say E was what? E was VCH plus IARA over IA. So that's how this formula came about. Then you just divided through by the IA to get this formula. So that's it. So this is the next formula worth noting. Now the last background formula to know is this minimum speed formula here. This one is not about formula, so this minimum speed formula here and the maximum speed formula here, has to know them. And once you know them, we can go ahead and answer the questions that come under this side. Yes, so the speed must stay between the limits of the maximum and minimum speed that we can achieve. Okay. Even a DC chopper is used in regenerative braking of a DC series motor. The DC supply voltage is 600 volts. The DC supply voltage is 600 volts. So let's try to draw what we have before what we don't have. Have it like this. DC supply is 600 volts, right? That's my VS here. Applying to a motor. But now I want to achieve regenerative braking. So we now want to supply this way. That's what we want to do now. Then it says that they're giving us RA here, they're giving us field resistance of this. The back EMF constant is this. Armature current is maintained at 250 amps. So the armature current will still be 250 amps, except moving in the opposite direction. If the duty cycle is 60%, duty cycle is 60%, find the average voltage across the chopper switch. This is 0. Do that. VCH is equal to what? We saw that it was equal to 1 minus delta times VS. So that's it. 1 minus 0.6 times VS 600. That'll be it for that one. B is find what? Find the regenerated power supplied to the DC. So the power you are getting from here. So P generated is equal to what? IA times what? VCH. P is IV. So the IA times the voltage there. So the VCH we found here, let's find it. 0.4 times 600. 240 here. Right, so this will be IA 250 times 240. 250 times 240. That's 60 kilowatts. 60 kilowatts. Then this part says that find the equivalent load resistance of the motor acting as a generator. So RE equivalent is equal to E, right? E over what? E over IA. And then E is equal to what? E is equal to VCH, the voltage here plus the drops, plus IA RA over IA. So the VCH found it to be 240 plus IA. IA is 250 times total resistance. So get the total resistance from here. This plus this. That's 0.05. So plus 0.05 all over IA over 250. So you punch that one too. That'll give you the equivalent resistance. Now once you have equivalent resistance here, find the minimum permissible breaking speed. The formula there. So yeah, so we have this here, we have this, we've done this here. Now find the minimum. Find the minimum permissible. So just put in the formula. The maximum, so you put it here. That's all. That's all. Then the F says that find the motor speed. Find the motor speed. The speed is what? V over KVIF minus RATE over KVIF squared. Right? So that's how you find the speed. That's how you go ahead and find it. Motor speed. This will be the chopper voltage. Then you go ahead and then you find your speed. So you might find the torque, and then you just go ahead and find your speed. So now your torque will be what? Torque is KVIFIA. Once I have that torque, I can just do this in the speed formula. V over KVIF minus RATE over KVIF squared. So that will be it. So you can solve it that way. You can also solve it the way they solve it here. To give you the same thing. So that's it. All this part was skipped. We didn't do all this part in class because it's not anywhere that's highlighted this one. We skipped all this part. That's for 4-7, right? Then 4-8-2. So this is where we are right now. 4-8. We skipped all this part too. So we'll just go and start from the induction motors. Speed control. This is how continue from. Speed control of 3-phase induction motors. Okay. So let me end this video here. Thank you very much.